Hello everyone. Today we're going to review for the law of sines and cosines quiz. You will be given the law of sines and cosines. So just remember, it is a quiz over law of sines and cosines. So make sure you're using those. Also, if you have a right triangle, use just plain sine or cosine. That's always going to be easiest. So look for that. So let's check out what we have here. We've got fishing boats, each traveling in a straight line. So that's important. Angle between their paths is 65 degrees. Okay, so we have two boats, each boat. So each of these straight lines is a boat, and the angle between them is 65 degrees. First boat averages 15 miles an hour, second is 25. How far apart are the boats after 90 minutes? Well, we're in miles per hour, so 90 minutes is 1.5 hours. We have to take 1.5 times 15 for the first boat's distance, and that is 22.5. Oops. And so one side, doesn't matter which one, is 22.5 miles. And then we have to take 1.5 times 25 miles an hour, and that is 37.5, and that will be the other side. And the question is, how far apart are the boats? So this is the space we are looking for. So we have side angle side, and side angle side is law of cosines. So you start with the side across from the angle that you know, and this is going to be side squared, which we don't know, equals, pick one, doesn't matter which one, and then add the other one squared. Then minus 2 times the two sides, again, because we're multiplying, it does not matter the order. And then, of course, we do the cosine of the only angle that we know. Now, when you type this in the calculator, of course, you can use the giant radical sign and just type that in directly as I have it written. You don't need to do anything extra. You don't need to add any extra parentheses. Of course, when you hit cosine, it will automatically give you that parentheses. But since this is the end of the problem, you don't need to close any parentheses. You can just hit enter, and you're going to end up with 34.63 or so. Let's check the directions. We are supposed to round to the nearest mile. So let's call this 35 miles. So explain why you cannot use the law of cosines if you know two angles and the included side. So if we know two angles and the side. So basically this is angle, side, angle. Well, law of cosines, we need more sides than angles. So we don't have the right information to fit what we would need for the law of cosine. So because we have two angles and one side. So law of cosines works for side, side, side. It works for side, side, side. It also works for side, angle, side. So again, more sides than angles. What's the measure of the largest angle with the sides of 3, 5, and 7? Okay. Any old triangle, doesn't matter. Put the sides anywhere you want. That doesn't matter. Obviously, 7 is the biggest side. The largest angle is across from the longest side. I don't even have my angles labeled. Let's just call this C. I don't know why I called it C. So now we're doing the kind of the reverse of problem number 1. So we know the side. It starts with side squared, so we know that. All right, that's 7 squared. And then we're going to take the other two sides and square them. I'm going to write them down as squared because it seems like that's easier. And then 25 minus 2. Now we're not squaring these. 2 times 3 times 5 times the cosine of the missing angle. So because this is reverse, you have to be careful with your arithmetic. All right, so we have to, this is a term and cannot be separated without division. So we do 9 plus 25, which is 34, minus, since all this is stuck together, 2 times 3 times 5, 30, cosine C. Remember, this is stuck together. So you subtract 34 from both sides, and you get 15 equals negative 30 cosine C. So then we're going to divide by negative 30, and you can type all this in the calculator, but you end up with negative 2 equals your cosine. So you want to do second cosine. All right, we want to find the angle. If you're keeping in the calculator, second cosine, second answer, and we end up with the angle being 120 degrees. Exactly, because 0.5 is on the unit circle, as you know. Okay, find all the missing parts. All right, let's see what we got. So again, when you draw a triangle, it doesn't matter if you draw, I have a tendency to draw on mine equilateral, and it doesn't matter how you label this. You cannot label a triangle incorrectly. That's the good news. So if angle A is 35, then across from there is side A. That's what matters. That's the only part that matters. Angle B is 60, and across from there is side B. And then side C, lowercase c, is 15. Okay. So it looks like we need to find angle C. We need to find side A. And we need to find side B. And you can use whatever. If you have a right angle, use sine or cosine. If you have the right thing for law of sines, use that. Usually something like this, you want to try to use the law of sines first because it's easier. Of course, we have 180 degrees. So we're going to do 180. You don't need to write this down, but I'm just trying to show you what we're doing. Minus 60 minus 35. That's how we're going to get angle C. So angle C is 85 degrees. And that's important because this is the only relationship we have in order to use the law of sines. So we can be pretty confident that's right because subtracting, we can't really mess that up. So the sine of 85 over 15 equals, and it doesn't matter what you do next. I'm going to do B next. Oh, maybe I should do A next. So A is across from 35. So the sine of 35 over A. Start on the diagonal where you know two values. 15 times the sine of 35. Hit enter, divide by the sine of 85, and we're going to the nearest tenth. So A is 8.6. I'm going to use the same relationship again because I'm feeling confident that those two numbers are correct. And since I have to find side B, I have to use the 60. So sine of 60. And again, we're going to go on this diagonal first. 15 times sine 60. Hit enter, and then do divided by sine 85. Hit enter. And B is 13.0. It's like 13.0000 something. So, oh my goodness, I don't know what's wrong with me. Sorry. 13, there we go, 0.0. This one is a picture, that's nice. So we have a reference point R and a reference line. Okay, let's see what that means. The survey measures the distance from the reference point to two other points P and Q and measures the angle, blah, blah, blah. Find the distance QR. Oh, we don't even have that distance, so I'm going to draw that in there. So this is what we're looking for, and I'm going to call that X. Well, X is across from this angle. So we need some angles. This is a right angle. I don't know why it's not marked. And this is a right angle. So 180 degrees in your triangle, you can do 90 minus 35. So this angle is 55 degrees. 90 minus 22. So this is 68 degrees. And then, of course, you have a straight line right here. These three angles add up to 180. So to find that missing angle, we do 180 minus 55 minus 68. And, of course, that missing angle is 57. And now we're ready to go. And this is going to be exactly like problem number 1, because we're looking for this. So x squared equals one side, doesn't matter, 148 squared, plus the other side, 215 squared, minus 2 times one side, times the other side, times the cosine of the angle across from what you're missing. And again, when you type this in, you can use the giant radical. And this says we're going, doesn't say. Just says find the distance. So we'll go to the nearest tenth, just because. So we're going to get 8x rather, or whatever QR, whatever you're calling it, right? Probably more appropriate to call it QR, equals 182.9. And this is, of course, in meters. On the quiz, you'll have kind of the same directions right here. two solution ambiguous case. So remember, when you have two solutions, you have to do everything twice. So again, looks like we have angle B, side. I'm just going to call it ABC because of the letters. We could call it ABX. It doesn't matter. We just have to use B, and it looks like we have to use A. So I'm just going to go A, B, C. And again, the order that you draw it in doesn't matter. Angle B is 52. The side across is 8. And the side across from A is 9. So the relationship matters. So what really matters is you have this, and that the 9 is across from the A. It doesn't matter if it's top like mine is. It could be left to right. It really doesn't matter. So we're going to use this. This is the only relationship we know, and automatically we're going to have to find angle A. That's automatically going to be our first angle because of the way the problem sets itself up. So we're going to do sine of 52 over 8 is equal to the sine of angle A over 9. Now we're missing an angle, so you're going to have to do inverse sine. So we're going to go 9 times 52 in the calculator. Enter. Divided by 8. Enter. Second sine, second answer. And so you get, we're going to have two cases. So I'm going to do angle A here. We're going to, angle A is 62.4 degrees. Now you know that's like a hinge. So you got to do 180 minus 62.4 to find the other choice for angle A. And then the other choice is 117.6 degrees. And now we have two triangles. But remember, angle B is not going to change. So 180 minus the angle you found minus 52. So now we know that angle C over this one is 65.6. And then angle C here, 180 minus 117.6 minus angle B, which is 52. And we get a very small 10.4 degree angle here. But it's enough to make a triangle, so we know we have two triangles. Now, only thing we have left to find is side C. So you're going to repeat the process. So we're going to use angle C. I'm going to go back to my original setup because I know those numbers are correct. So I have the sine of 52 over 8. I have to find C. Sine 52 over 8, and I'm going to have a different value for C here. So on the top would be angle C. So the sine here of this one's 65.6, and this one would be the sine of 10.4. And so it just feels very repetitive, but with some different numbers. So in the first triangle, side C is going to be bigger because this is a bigger angle. All right, so this one should be larger than this one over here. So again, I start on the diagonal where you know two things. 8 times the sine of 65.6 divided by the sine of 52. This is not second sine. You're just going to get the answer. It's going to spit out. We'll go to nearest tenth. Oh my goodness. Sorry, I can't write. 9.2, no units. Over here, we get, again, 8 times the sine of 10.4 divided by the sine of 52, 1.9. Make sure your answers are labeled so that it's very obvious that you know what you're missing and that you found everything that you need. Sorry, this is just a little blob. Again, you don't have to label it case 1, case 2, but you do need to make sure all the pieces are labeled that you had to find. Ooh, number 7. A little throwback from geometry, angle of elevation. Angle of elevation from point X. Okay, point X. 80 feet away from the base of the tree. Here's my tree. I'll even make it green. Tree. There we go. It's a good tree. Now, angle of elevation, what that means is you go from straight out to up. So this is your angle of elevation in that space right there. So angle of elevation, so from X straight up to the tree is 52 degrees. And then this is your 80 feet. It does not seem like we have a right angle because your tree is leaning. You're probably wondering why I drew my tree like that. It's not straight up and down. The tree is leaning towards, so that's why it's not straight up and down. It's leaning this way. So this is an 85 degree angle. So we do not have a right triangle. So we have to use law sines or cosines. You can't just use plain sine, plain cosine. What's the of the tree to the nearest foot. Oh, okay, so we're looking for this. And if you need a triangle, there's the other side. So we have angle, side, angle. And we need to know what this is because then we can set up lost signs. So subtract 180 minus 52 minus 85. Your missing angle is 43 degrees. And now we're ready to go. Sine of 43 over 80 is equal to, well, we might as well do this. This is the only one we need. Sine of 52 over x. Easy. Cross multiply is not an angle, so you don't have to use inverse. And we get 80 times sine 52 divided by sine of 43. You get it right around 92.44. Directions say nearest foot. So we'll call that 92 feet. It's a tall tree. Last problem. This is the hard one. And it obviously it's perimeter on the quiz too. So remember, you are, oh, what's happening? You are using lost signs and cosines. I don't know if that's obvious. Oh, I hope it is. I don't really know what to do with my shape. Jeez. I'd like to have a right angle. So let's sort of think this through. Here we know this. This is 80. This is 120. I don't really want to slice these angles because I don't understand how they get sliced. Do I? You got to pick one angle to kind of cut up and one angle to keep. And it doesn't look like I'm going to get a right angle anywhere. I'm just trying to come up with a plan. I think I'm going to go this way. I don't know why. It doesn't really matter which way you go. I'm just going to go that way. Because either way, you have side, angle, side, side, angle, side. So you pick how you want to do it. I'm going to go this way. So I'm going to take this and I'm going to slice my shape this way. Again, you have an option. You don't have to do it my way. All right, so here's kind of where my dotted line would be. So I know this is 125, this is 80 degrees, and this is 130. I don't really know what else to do. So let's try this. If we find this, that's going to actually be in both triangles, and that might help me, right? Because it's in both triangles. So I'm going to find the side that's in both triangles. I remember you don't know this angle right here. You don't know this angle up here either. So we have side, angle, side though. So that's law of cosines. So x squared, and it's the easy version of law of cosines. So x squared equals 125 squared plus 130 squared minus 2 times 125 times 130. And we have the cosine of 80 right there. Square root. And I'm going to try to use a lot of decimals here just because I want it to be exact. I'm going to go with 163.96. So this is now 163.96. I don't know if that helps me. You need this. This is ultimately what we need right here. All right, to get the perimeter. But the only problem is we couldn't pick that triangle because we don't know anything really in this triangle besides the 100 feet. So that's why we have to start with the bottom triangle. I need an angle. I'm going to find this angle right here. Right. So sine, right? We know this relationship. So sine of 80 over 163.96 is equal to the sine of 125 over sine of, oh, I guess I'll call it A. Gotta call it something. Now you're finding an angle. So remember, you got to do inverse sine. So we get multiply, divide by the sine of 80, second sine, second answer. So angle A is 48.7. I don't really want angle A though. If you think about this top half, that all we're trying to get is that missing side. And so what I just found was this piece right here, 48.47. So I know this angle is 120. So I got to do 120 minus 48.7. And then you get 71.3. So that's what we need. So this is 71.3 degrees. This we know is 163.96, and we know this is 100. And look, we're at side angle side again. And so I'm going to call this y. We can find that missing side. So y squared equals 163.96 squared plus 100 squared minus 2 times 163.96 times 100 times the cosine of 71.3. Yikes. Square root, and we end up with y equals 162.39. And so now we have all the sides we need. So add up 125, 130, 100, 162.39, and the perimeter is 517.39 feet. There you have it.